Hello world, Noah here. In this video we're going to be talking about bit masking, which is a somewhat advanced concept that involves storing multiple values in the bits of a number. Before you start watching this video, you should watch my videos on bitwise operators and bit shifting. You can find them on my channel because if you don't have that sort of foundation, then what I'm going to say here won't make sense, because I'm going to assume that you know how to do things like and, or, and not, and how to shift bits, or what exactly it means to shift bits. Okay, so what exactly is bit masking? So imagine for this example we have a printer, and we want to store a bunch of information about the printer, a bunch of status information. So three things that we might want to store would be the power status, whether the printer is on or off, the paper status, whether there is printer or there isn't printer, and the toner status, whether there is toner in the printer or not. Obviously, there are plenty of other values that we could store, but I want to keep it rather simple, so we're going to do this with just three values. Now, normally, I would probably represent each of these three values with a boolean, a true or false value. So in the case of power, true would mean that the power is on and the printer is turned on, and a 0 would mean false, it would be false, and that would mean that the printer is turned off. And as we know, we can represent a boolean with a 0 or 1, where a 0 means false and a 1 means true. So instead of having three separate boolean variables, we know that each boolean variable is 1 bit. We could take these three boolean variables, which together would make up 3 bits, and we could store all three of these bits in a single variable. We could store all three of these bits in an integer, for example. So before we get started and take a look at exactly what that means for us, we need to just remember that we're working in binary in this case. We're working with binary numbers and the bits of binary numbers. And so in Java, there's a couple of tools that we can use to help us with that. And so, for example, if we want to define a number in terms of binary, let's say that I want to write the number 4 in binary, which we know is 1, 0, 0. There's a 1 in the 4's place, nothing in the 2's place, and nothing in the 1's place. But in this case, it's actually just the number 100, which is not helpful to us because we need it to be in binary. And the trick that you can do here is you can prefix a number with the number 0 and a b. So for example, 0b100. And so just to show you, if I print out x without that, it's of course going to print out 100, which is not good. But if I put the 0b in there, it will print out 4 because I'm saying to treat this as a binary number. And so it says 100 is binary for the number 4. And so now we know that we're treating it as the number 4. And then finally, if we have a number that's actually a decimal number, so for example we have 10, and we needed to convert it, because let's say we got this number 10 back from like a return from a method or something like that. We're not in a position that we could just put a 0b in front of it. We have it as a decimal and we need to convert it. The easiest way, if we're just printing it out, is you can do integer.toBinary string, and you just give it the value. So in this case, it's going to print out 1010, right? Because if we have the number 10 originally, that'll basically be an 8 plus a 2. And to make it a little less confusing, let's just say that we have the number 6. It will print out 110, basically a 4 and a 2 and not a 1. So 4 plus 2 is 6. So if we have the number in decimal form, we can convert it to binary form by using toBinary string. Obviously that'll give us a string back and not an integer, but we're just going to print it out, so that's fine. And if we're actually writing the numbers themselves, then we can write them just 0b, blah, 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 so on and so forth. Now, just be really careful about this, because let's say that I'm trying to write the number, like, I don't know, 12, for example, and I put the 0 in front of it, or I guess that doesn't make sense. Let's say I'm trying to write the number 11, or I'm trying to write, binary for 11, so I write this, and I forget to put the 0b in front of it, and so then it should print out 11, but it's actually not. It's going to print out the number 9. And the reason is because when you start a number with just a 0, then Java thinks that you're talking about an octal number, which is a base 8 number. And in this case, it prints out 9 because we have 1 8 and 1 1, which means that the value would be 9. So just be careful. You can't start a number with a 0 unless you put the prefix, so like 0B001. In this case, it'll work as expected and give us a 3. We know that's a 2 and that's a 1, so it would add together and give us a 3. But if you don't have that prefix and you do have a 0 in front, it'll treat it as octal. Now, if that was confusing to you, don't worry about it. It's not important. But if you run into this situation and you think this should print out 11, but it's actually printing out 9, then now you know the reason why. But without further ado, let's get started. The first thing we're going to do is we're going to define this variable, which we're going to call status, because it's keeping track of a lot of different printer status informations for our printer. And we're going to set this equal to 0B010. And so what that will mean is we'll say that this bit right here, this far bit that is highlighted, will be for power. So the fact that it's a 0 means that the power is off. This one in the middle, this middle bit will be for the paper. So the 1 means that there is paper, and this last bit on the end will be for the toner, and a 0 means that there is no toner. So we can actually just write this out. We can say the first digit is power, or sorry, the first bit is power, the second bit is paper, and then the third bit is toner. So just so we can keep that in mind. Now, an integer in Java is a 32-bit data type, which means that we could store 32 different variables, or maybe 31, because I think one of the bits is used for a sign. Not 100% sure on that, but you could store 31 or 32 values in an integer, which is obviously quite a lot. And so we don't actually need that. We're only using 3 of them here. But obviously, if your printer had more status variables, you could probably fit all of them into a single integer value, which is kind of cool. Now, of course, since we didn't specify, there's just a bunch of zeros right here. So just keep that in mind. There's just a ton of zeros there, but we don't need to specify them. They'll just implicitly be a 0. So our status variable is 0B010. And so the first thing that we want to do is we want to be able to check, we want to check a bit to see if a bit is on or off. And that's a pretty simple thing to do with this. And so essentially what we want to do is, let's say that we want to check paper status. We want to know whether there is paper in the printer or there is no paper in the printer. The first thing that we need to do is we need to create a mask for the paper bit. And so essentially what that means is that we need a number where the entire number is just filled with zeros. All the bits are zeros, except the one position that we care about is set to a 1. So essentially in this case, I'm going to call this paper mask. And we basically want a ton of ones, or a ton of zeros, and then a single 1 where the paper is, and then another 0, like that. But rather than actually type out all of the zeros, which would be kind of silly, of course you don't need to do that. You could just do 0B010, for example, or 0B10 or whatever. But maybe a cleaner way of doing it is you could take the number 1 and you could left shift it, by 1. And so what that would do is, if you originally just start out with the number 1, so the number 1 by itself in binary is just 001. And if you shift it over to the left by 1, then it'll go over and it will become 010, just like that. It's pretty simple. So basically, we can just take the number 1 and we can shift it over by 1, and that will give us a mask where all of the bits are 0 except there's a 1 in the place that we care about, which in this case is the paper bit. And so once we have this mask, we can just do an AND operation with the status and the mask to check on the status. Before we actually write that, let's just take a look at what that would do. So in this example, our status is 010, and we're going to do an AND operation with 010, which is actually the same number. So hopefully that's not confusing. But in this case, we know that the paper is on, So in this case, we should get some sort of a result that indicates that the paper, that there is paper. So let's just say, in this case, there is paper, and so we should get a result that indicates that. We start from the right, although it doesn't really matter. 0 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0. So the number that we get is 0, 1, 0, which is actually equal to the mask. And this is a little bit confusing. So let's say that we do actually have toner. I just put some toner in the printer, so this value is now a 1. Let's just make this a little cleaner. So in this case, we have 0, 1, 1, which is our status. Printer is off, there is paper, and there is toner. We have our mask, where there's a 1 for the paper and a 0 for everything else. We do the AND operation, and we get 0, 1, 0, which incidentally is equal to the mask value that we had before right there. Now let's just imagine for a second that there isn't paper. So now there isn't paper. So we can take the same status, but this time we're turning paper off. So basically the printer is off, there is no paper, and there is toner. And so if we do the AND, we're obviously going to use the same mask again, and we get the value 0, 0, 0, which is of course equal to 0. And so basically, when you generate a mask for a specific bit, like this, and the bit is a 0, then the result of your AND will be a 0. So in this case, there is no paper in the printer, I do my AND, and I end up with the value of 0. Now in this case, there is paper, so when I do my AND, I get a result that's not 0. Now the result depends on the place that it's in. So for example, this is in the 2's place, so the result is 2. If this were here in the 4's place, the result would be a 4. But essentially the idea is that the result is not 0, and it will actually be equal to the original mask. And so what you can do is we can basically get the result of is there paper, and we do that by saying status and paper mask. So we do the and then if we want to check, we can basically say, we could say if the paper result is equal to 0, then we know that there is no paper. So we could say there is no paper. And then we could just do an else statement and say that there is paper. But the other thing you could say is you could say if the paper result is equal to the mask. So if the result that we get right there is equivalent to the mask that we used before, that's another way you can tell that there is paper. So just to put all of the different options here, there is paper. Basically, if the result is 0, there's no paper. If the result is not 0, there is paper. Or if the result is equal to the original mask, then that's another way of being able to tell. Although since the original mask is not 0, this would obviously be true. But it's just something to notice that it's not some random number, it is actually the mask. So just something to keep in mind. And just to see if we run this for a second, it will tell us there is paper. Of course, it'll say it twice because we had that, but that makes perfect sense. And if I go into the status and I get rid of it, then it will, of course, tell me there's no paper. So this is a good way of checking to see whether a bit is turned on or off. You just generate the mask for that bit, you do an AND operation, and you check to see if the result is 0 or not 0, or you could see if the result is equal to the mask or not equal to the mask, however you want to do it. So I guess you could actually just have an else statement in here, and you could say there's no paper. So basically, whatever way you want to deal with that is fine. Now we're going to talk about how to actually change the status. How can we actually change a bit here? And so what we can do, there's basically a couple ways to do this. I'll show you first one way that toggles. So you could basically run the same operation a bunch of times and it'll go on, off, on, off, on, off. And then there's a way you can do it where there's an operation that just turns it on and it'll stay on however many times you do the operation, and then a different operation that'll turn it off, and however many times you do that operation, it will stay off. So let's just do the toggling one for a second. So basically, let's imagine that we want to restart our printer. Or basically, we want to turn our printer on, and then we want to turn it back off. But first, of course, we need to turn it on because it's currently off. So let's take a look at how to change this 0 right here into a 1. The first thing that we want to do, and so this is for checking the paper status, and this is for turning the printer on. Turn printer on. That's what we want to do now. Okay, so the first thing we need to do is we need to generate the mask for the power bit. And as we know, we need to basically just take the number 1 and we need to shift it over 2 times. We shifted it over once to get this middle bit for the paper. We need to shift it over 2 times to get the bit for status. So we can create power mask, which is the number 1 shifted over to the left twice. And we know that this will give us 0B100. And that, of course, lines up with our status. That 1 lines up with the status right there. And so now what we can do is we can actually just use the exclusive or XOR operator. I don't even know if it's supposed to be called XOR, but that's what I'm going to call it. So we can use the XOR operator to actually work with this. So our current status is 011, and we want to do the XOR operator on 100. And as you remember, the exclusive OR functions like an OR operator, but if 2 values are a 1, then it will turn that into a 0. So basically, you can have one or the other, but you can't have both. If you have both, it will be false. Okay, so if we do the OR here, the result would, of course, just be 111, because we have 0, XOR 1, 1 XOR 0, 1 XOR 0. I guess we should start from the right and not the left, but it doesn't really matter. So we get a result of 111. These 2 bits up here did not change, but the result up here did change. The 0 changed into a 1. So we left everything else alone, but in this case, we actually turned the printer on. Or I guess instead of saying turn printer on, I should say toggle printer power, because we're going to do on and off separate later. Now, if I run the same exact XOR operation again, using the same exact mask, I start over here, and we know, 1 XOR 0 is 1, 1 XOR 0 is 1, but when we get to 1 XOR 1, that result will actually be a 0. So we end up with 0, 1, 1, which is what we originally started with. So that's what we originally started with. Again, these other 2 bits have remained unchanged the whole time, but this first bit has kept changing. And of course, if we run this operation again, it's the same thing that we just did up here, so it'll toggle on and off and on and off and on and off. So we can use the XOR operator, and because that basically the reason why that works is because if we have a 0 and we XOR it with a 1, we get a 1. If we have a 1 and we XOR it with a 1, we get a 0. So it'll just keep toggling back and forth, which is exactly what we want to do. So in this case, we can say well, I guess we want to change the status here. So we want to set status equal to status XOR power mask. So essentially, we're taking the status as it is right now, and we're XORing it with the power mask, and we know that that's going to end up changing this 0 into a 1. And so if we want to print out the results of status, well, we could just print it out like that, but it's going to give us the number 7, which isn't terribly helpful. Since we're working in binary, we want it to print in binary, so we can just use that trick to binary string, and we'll print out status. And if I run this, it will say 111, which is exactly what we had there. And if we do this again, so this first operation will turn it on, and then the second operation will be to turn it off. So it'll first be 111, then it will be 011. There is actually a 0 in front of it, but it just doesn't print it out. But essentially, yeah, there's a 0 there, and it's a 1-1, so that's exactly what we expect to get. And of course, if I ran this again and again and again, it would keep toggling back and forth, and that's great. So basically, you could do that whenever you hit the button on the printer, you could use the XOR operator with the power mask to turn the printer off or on based on whatever its current status is. But let's say that we want a way to turn it on and just on, or a way to turn it off and just off. We want basically we want them to be idempotent. I don't know. Basically, that just means that we can apply it as many times as we want and nothing will change. We basically apply it once, it'll change something, and if we apply it any more times after that, it just won't do anything. And so then what we'll do is we're going to say turn printer on. So we're just going to turn the printer on because right now it's off and we want to turn it on. So again, we will need the power mask, which we already have. I'm just going to redefine it here so that we have it, just like that. So we have our power mask, exact same thing, because of course the mask is just going to be the same. It's a 1 in the place we care about and a 0 everywhere else. And so what we can do here is we can just use a regular old OR instead of a XOR. So if our original starting power is 0, 1, 0, and we do just a regular old OR with our mask, which is 1, 0, 0, then what do we get? We get 1, 1, 1, which is what we expect. The power was off, and now we just turned it on. But if we run this again with the exact same value, 1 or 1 is 1, and 1, 1. So you can see that we get the same value again. And of course, if I round this again, it would just keep giving me 1, 1, 1. So this operation will turn the printer on, and if you keep running it, it will just not change anything. It'll leave the printer on. And so to do this, we would just say status is status or power mask. And then let's say, so this will basically, whoa, I did not mean to do that. We'll basically just say turns the printer on, and that's it. It won't toggle or anything like that. And if we run it, it will of course print out 1, 1, 1. And if I copy these two lines and I run it again, you'll see it says 1, 1, 1, 1, 1, 1, because as we know, it won't change anything after it happens once. Now we want to turn the printer off. This is a little bit trickier, as we know we can't just apply the OR operation again, because that will just leave the number the same. Of course, you could use the XOR, but that kind of defeats the purpose. We want something that will just turn the printer off, and that's it. And what we want to do, the first thing we need to do is we need to find the inverse of the power mask, or the inverse of the mask of the bit that we care about. So in this case, we basically need a number where all of the bits are a 1, except there's a 0 in the place that we care about. It's the opposite of what we were trying to do before. And so what we can do is, I'm going to call this inverse power mask. And you can basically just say, you can use the binary not operator on the original mask, just like that. So this will basically just invert all of the 0s and 1s. All the 0s will become 1s, all the 1s will become 0s. And this is essentially the exact same thing as just actually putting the 1 shifted 2 in parentheses, but we can use the power mask variable since we have it. Let's just take a look for a second at what this looks like, because if you go to print it out, you might actually be a little bit confused because there's a ton of 1s in front of it. Remember, this is a 32-bit number. If you count this up, there are indeed 32 digits in this number. And we said these were all 0 before, but now they're all 1. And you might think that that actually makes a difference, but it really doesn't. Because when we go to do an operation, we know that this status number has a ton of 0s in front of it, right? And we're going to do an AND operation with the status and this inverse. And since these are all 0s in front of it and those are all 1s, a 0 and a 1 is a 0, so they'll basically just be knocked out anyways, so it doesn't really matter. So the fact that all of those 1s are there won't end up mattering. The important thing is the last 3 digits, and that's good because we had 1, 0, 0 before, now we have 0, 1, 1, which is indeed the inverse of what we had, so we're good to go with that. As I said, we want to do the AND operation between these two. So our current status is 1, 1, 1 because the printer is currently on. So we want a 1 in the power place, which is right there. And we're going to do the AND operation with this inverse. And the inverse is 0, 1, 1. And so if we do the result, we get a 1 and a 0 is a 0, a 1 and a 1 is a 1, 1 and a 1 is a 1. So we get 0, 1, 1, which is the printer is off, but the other 2 bits remain unchanged. And if we run this again, we'll just get the same thing again. A 0 and a 0 is a 0, 1 and a 1 is 1, 1 and 1 is 1. So as you can see, we get 0, 1, 1 again. And as many times as we wanted to run this, it would still give us 0, 1, 1. And so the reason why this one works is because we're using the AND operator. So basically, it will take this 1 here and turn it into a 0. But if this were already a 0, then the result would still be a 0. And then all the other ones, if they were 1s, they will of course remain 1s because of the 1 and 1. But if this was a 0 up here, for example, we know 0 and 1 would be 0, so it would remain a 0. So this still works. Again, we still have all these 1s in front of it. So we have all these 1s in front of our bit mask. But for all of those 1s, there's a 0 in our original status number, and we know that a 0 and a 1 is a 0, so we will basically just end up with a bunch of zeros like that, and we can just ignore it. So that's why this works, even though there's a bunch of 1s there now. So to actually do this, we want to change our status variable again, and we basically, we want to do status, and we want to AND it with the inverse power mask, like that. And now we can print out our status, and the result that we get out of that will be 1, 1, or 0, 1, 1, which is exactly what we expect because now this first bit has been turned off, but all the other bits are the same. We're just about done, but I'm sure you might be wondering, you know, this looks a little bit messy. It looks a little bit confusing. But this is out in the wild. There are plenty of applications. There are plenty of software packages and that use this. So if you look at source code online, especially if you're working with like OpenGL, for example, you will definitely see this. But to make it a little bit cleaner, what generally happens is all of these masks are defined as constants. So let's just do that for a second. Public static final int. So for example, power, we know is the number 1 shifted over twice. So that would be that bit right there. We know that the paper status is the number 1 shifted over once. And we know that the toner status is the number 1 shifted over 0 times, which is just the number 1, but I'm going to write this just to, you know, just to keep the consistency. But basically, these variables are defined there, and so now what happens is you don't need paper mask anymore because it's already been defined for you. And if you want to check the paper status, you just AND with this paper status number. Now, you don't care the order of these bits in here because that's already been decided by the developer, in this case, me. I already decided that power goes in this bit, paper status goes in this bit, and toner status goes in this bit. And I just let you know by naming these variables and giving them the appropriate values. So when you do status and paper status, you don't know which bit, you don't necessarily know which bit you're talking about. But the important thing is that since paper status is the mask for the paper bit, this will indeed work. And so it's a lot less confusing. And of course, we would change it there, like that. Of course, we don't need power mask anymore because we would now just have power mask. So again, if you want to, sorry, I think it's just called power. So again, if you want to toggle the printer, you just take the status and you XOR it with this power variable. You don't care what value power has. You don't care which bit power is being stored in. You just know that it is because I created this variable called power for you. Very simple. And of course, that'll go here, and we can still do the binary not operator on it and all of that. So this is basically how it would work, you know, if you were to actually try and implement this into your code. You would have this integer, you have one integer to store all your values. You would decide what each bit represents, and then you would basically create these constants for each bit that you're storing in there, and each of these constants would be equal to the bit mask for that constant. Basically, the number 1 shifted over the number of times to get to that bit. And so, of course, if we excuse me, if we wanted to add more status things. We could add something that's 1 shifted over 3 times, 1 shifted over 4 times, 1 shifted over 5 times, so on and so forth. And we wouldn't need to create new Boolean variables. We wouldn't need to create new getters and setters. We wouldn't need to do any of that. We would just simply create one new constant for each of these values that we want to add to our status variable, and then everything would immediately start working just fine. So that is all for this video. As always, subscribe if you want to see more, comment with what you want to learn, and if you like this video, hit that like button. I will see you soon with some more coding videos. Bye for now.